Coastal megacities confronting sea level rise. One of the most significant threats facing the world's cities by 2050 is sea level rise. Many of the planet's largest urban centers lie on coasts, deltas, or river mouths, where sinking land and rising oceans intersect in dangerous ways. Cities such as Jakarta, Bangkok, and Mumbai illustrate how population growth and rapid development amplify risk in regions already prone to flooding. Jakarta, in particular, has become emblematic of the struggle against subsidence, as decades of over-extraction of groundwater have caused the city to sink at alarming rates, with projections suggesting that large portions of the city could be underwater within decades. Indonesia has even begun the unprecedented task of relocating its capital. Bangkok faces similar challenges, sitting barely above sea level and sinking gradually each year. The city's dense urban development and shrinking natural water absorption areas make even moderate monsoon rains hazardous. By 2050, projections indicate that significant parts of the city's metropolitan region may experience chronic flooding, forcing adaptations in housing, transportation, and public services. Meanwhile, Mumbai confronts both sea level rise and powerful cyclones that strike with increasing frequency. Its large informal settlements, many of which occupy vulnerable coastal or low-lying land, face severe risk. The combination of dense population, aging infrastructure, and socioeconomic inequality means that climate impacts disproportionately affect the most vulnerable residents. Heatwave capitals of the future. Rising global temperatures are expected to make heat waves one of the most dangerous and widespread climate threats. Cities in South Asia, the Middle East, and parts of Africa are projected to experience extreme heat conditions that may surpass human survivability thresholds. Places such as Delhi, Karachi, and Lagos represent future heatwave hotspots where rapid population growth intersects with inadequate infrastructure and energy constraints. Delhi already experiences summers that regularly exceed 40 degrees Celsius, pushing the limits of health systems and power grids. By 2050, these heat waves may intensify to the point where exposure for even a few hours can become lethal. Karachi faces similar pressures, with its vast population and limited green spaces contributing to soaring temperatures. Heat waves in recent years have already resulted in significant loss of life, underscoring the city's insufficient cooling infrastructure and strained electricity network. In Lagos, rapid urbanization has led to sprawling informal settlements that lack proper ventilation, access to electricity, or resilient building materials. Extreme heat conditions will not only challenge public health but also stress water supplies, food systems, and transportation networks. In these cities, heat is not simply a discomfort. It is an existential threat that will force major shifts in how people live and work. Water scarcity in expanding cities. While many cities will struggle with too much water, others will face the opposite challenge. Cape Town, Sao Paulo, and Mexico City exemplify urban regions where water scarcity has become an increasingly urgent issue. Cape Town came close to day zero in 2018, when reservoir levels plummeted dangerously low. Although the crisis was temporarily averted through severe restrictions and favorable rainfall, the close call highlighted the city's vulnerability to prolonged droughts driven by shifting climate patterns. Sao Paulo's water crisis underscored how mismanagement and climate variability can combine to threaten essential resources. With a population exceeding 20 million, the metropolitan region depends heavily on reservoirs that are increasingly stressed by changing rainfall patterns and deforestation in surrounding regions. Mexico City faces one of the most complex water challenges of all. Built on a drained lake bed, it relies on aquifers that are being depleted faster than they can recharge, causing the city to sink while simultaneously running short on water. By 2050, many urban centers are likely to experience water shortages that disrupt industries, spark social unrest, and force governments to rethink long-term sustainability strategies. Storm-exposed cities in the path of intensifying cyclones and hurricanes. Cities located along major storm pathways are expected to experience more frequent and more destructive tropical cyclones by mid-century. Manila, New Orleans, and Guangzhou illustrate how storm exposure, combined with population density and economic importance, create high-risk urban zones. Manila is regularly struck by typhoons that cause widespread flooding, landslides, and infrastructure damage. As sea temperatures warm, storms are projected to become more powerful, hitting an already vulnerable city struggling with poverty, overcrowding, and limited drainage capacity. New Orleans, still recovering in many ways from Hurricane Katrina, remains at high risk due to its location below sea level and reliance on levees and pumps. Sea level rise threatens to overwhelm these defenses, making future storms potentially catastrophic. Guangzhou, a major economic hub in the Pearl River Delta, also faces heightened storm risk. Typhoons in the region can cause enormous economic losses, and with the city continuing to expand, the cost of inaction becomes increasingly severe. For these cities, climate resilience will depend on fortified infrastructure, robust emergency planning, and international cooperation. Cities threatened by land subsidence, often exacerbated by groundwater extraction, adds another layer of risk for cities already confronting sea level rise or flooding. Beyond Jakarta and Mexico City, cities such as New Orleans, Bangkok, and Ho Chi Minh City face similar threats. Ho Chi Minh City, for example, has experienced rapid economic growth and urbanization. But this expansion has placed immense pressure on groundwater resources. As the ground sinks, the city becomes increasingly susceptible to tidal flooding and storm surges. Subsidence is a silent threat, one that moves slowly but has profound long-term consequences. As the land sinks and the sea rises simultaneously, even minor storms can have major impacts. Addressing subsidence requires sustainable water management, strict development regulations, and significant investments in modern infrastructure. The expanding risk to African coastal cities. African cities such as Alexandria, Dar es Salaam, and Abidjan are emerging as climate risk hotspots due to rapid urban growth, limited planning capacity, and exposure to coastal hazards. Alexandria, with its historic neighborhoods and economic importance, faces rising sea levels that threaten to inundate coastal districts. Damage to cultural heritage sites, homes, and transportation networks could reshape the city dramatically by 2050. Dar es Salaam, one of the fastest-growing cities in the world, lies in a low-lying coastal zone that is increasingly prone to erosion, flooding, and storm surges. With limited formal infrastructure and extensive informal settlements, climate risks have the potential to affect millions. Abidjan confronts similar pressures, with its location on a lagoon system making it vulnerable to both oceanic and freshwater flooding. As populations increase and urban expansion continues, these cities face a narrowing window to upgrade their infrastructure and implement adaptive strategies. African coastal cities in particular highlight the link between economic development and climate risk, as insufficient resources often hinder the implementation of effective long-term resilience measures. Inland cities facing environmental transformation. Even cities far from the coasts are not immune to the effects of climate change. Phoenix, Beijing, and Johannesburg illustrate how rising temperatures, air pollution, and shifting rainfall patterns can reshape inland urban environments. Phoenix already endures extremely high summer temperatures, and by 2050, these conditions may intensify to the point where outdoor labor becomes nearly impossible during peak heat months. Energy demands for cooling will rise dramatically, placing enormous strain on power grids. Beijing faces a combination of heat, air pollution, and water scarcity, all of which are likely to intensify. Climate change may reduce water availability in northern China, complicating the city's reliance on large-scale water transfer projects. Meanwhile, Johannesburg confronts shifting rainfall patterns that threaten water supplies and agriculture. Inland cities often lack the dramatic imagery of coastal flooding, yet their climate risks can be equally severe, affecting food security, health, and economic stability. The social dimension of climate risk. Climate vulnerability is not determined by geography alone. Social inequality, governance gaps, and infrastructure deficits play major roles in determining how severely a city will be affected. In almost every city facing climate threats, The poorest residents experience the greatest risk, and formal settlements are often located in flood-prone or unstable areas, lack basic services, and have limited access to emergency support. These communities may have inadequate housing materials, insufficient cooling, or no reliable water supply, leaving them exposed to the harshest climate impacts. As climate events intensify, social tensions may rise, highlighting the urgent need for inclusive planning and equitable resource distribution.